Hi folks, glad to be back at DPS speaking again, though virtually from other side of the world. I hope you're enjoying the conference. It's my pleasure to be presenting a topic on Azure SQL that everybody looks forward to. The topic is what to use when and product updates. My name is Ajay Jagannathan. I'm one of the principal group product managers in the Azure SQL team. We are responsible for building the service, helping customers migrate, as well as ensuring that they are successful on our platform. You can follow me at my Twitter handle or the team's Twitter handle listed here in the slide. So what are we going to talk about today? The main topics are we will cover what are the various Azure SQL offerings that we have for you depending on your workload. More importantly, what to use when. We'll also talk about different customers who have successfully used different application patterns on Azure SQL and why they picked those destinations. And finally, we will end the session with product updates on some of the new capabilities we have launched in the past few weeks to months. So with that, let's get started with Azure SQL offerings. So before we go deep into each of the offerings, let me give you a high-level overview. Azure SQL is a family of cloud databases offered by Microsoft for SQL Server. So it could be SQL Server running on a virtual machine, which is basically similar to your SQL Server on-premises instance, but just hosted on Azure infrastructure. It's best for lifting and shifting workloads, both OS and SQL, to the Azure environment without having to worry about managing your infrastructure. On the PaaS side, we have two choices. One is Azure SQL Managed Instance. This is your full-blown SQL Server engine as a managed service. So instead of having to manage the service, Microsoft will manage it for you, and all you have to do is run your applications and fine-tune it for the workload you're desiring to run. And then you have database as a service. So instead of a full instance, if you just need a single database, depending on your application pattern and the features that you want to use, you can just do database as a service instead of the full instance. And both of these are built on the same Azure Service Fabric. So what that means is all the built-in capabilities like automatic upgrades, patching, version management, high availability, backup strategy is all automatically taken care of, so you don't have to worry about it. And within each of these deployment choices, you have multiple tiers we'll talk about. Now, no matter which deployment option you choose, whether it's IaaS, Managed Instance, or DB, one of the beauty of this is the familiarity. It's built on the same good old SQL Server, which has been in the market for more than 30 years that you're all familiar with. So you can use the same languages to interact with the product, whether it's using the same tools that you're used to, like Azure Data Studio, Management Studio, Azure Portal, even if you're a command line or PowerShell geek, you can use that also. And finally, from a flexibility perspective, your deployment platform is also very flexible in the sense you can build on Windows or Linux environment, on containers, on Docker, and then deploy it anywhere from edge to cloud. So that gives you the mobility of your application with SQL from edge to cloud. Now, one of the biggest questions that we get is how does it perform compared to on-prem? So a third-party analyst, GigaOM, did a detailed performance benchmark against Azure SQL and comparing it with Amazon, and you can see that whether you pick IaaS or PaaS, Azure provides the best platform for SQL because it's a Microsoft product. SQL runs best on Azure, and price performance savings, you get more than 86% with 3-year reserved instances, whether you choose IaaS or PaaS. Plus benefits like Azure Hybrid Benefit, which is only unique to Azure, lets you move your existing license from on-prem to cloud and get the full price benefits as well. So with that, let's move on to what to use when. So with the multiple choices I talked about, it's really important to understand what are the sweet spots for each of these options. So that'll help you decide what platform to pick. So before we go into very specific guidance, let's look at common customer challenges that we see and what motivates them to pick a specific platform. So in this challenge, you can see that customer wants to migrate to the cloud as fast as possible, but they want full control of the environment. So everything from the OS version to SQL Server functionality. So the best solution in this case is host the SQL Server in an Azure virtual machine, because it gives you full control of your SQL Server and OS. You can pick and choose your OS type, your feature set, and all the other services in addition to engine. But what is unique in Azure for running VMs is we provide free extended security updates for SQL 2008 or R2. So if you still have really old versions still running that your application depends on, you can move them to Azure and still be compliant, because we give you free updates. And some of the other manageability features like backups, HADR, etc. And we invested heavily to improve the performance. So you can see that there's a lot of benefits of running these kind of workloads on VMs in Azure. A customer who chose this platform is Allscripts, a famous healthcare software provider, and they moved a lot of VMs, more than 600 VMs, because some of the features they were using and the control they needed, SQL on VM was the best suited platform for them. Now, what else do we have in VM to get you more benefits? Some of the key principles for us is to continue to invest to make sure we give you the best price performance, the leading security features that SQL already has. You can extend it in Azure, such as with AKV integration. You can bring your own keys, encrypt your databases, and store it there. We provide automatic patching and updates if you have the extension enabled, as well as backups, and high availability configuration has been made simple. So the simple message I want to drive is definitely install the IaaS extension agent. It is not installed by default. If you bring your own VMs, you have to register and install it. I'll show you how to do that. If not, if you install a gallery image, it automatically comes with this. Plus, you can also use that to get licensed management, where you can switch between hybrid benefit and pay-as-you-go and save costs accordingly. So a lot of benefits by using the IaaS agent extension. Here's a quick snapshot of all the different capabilities that the agent offers. So out of the box, if you have a bring your own VMs, you do not get any of the capabilities listed on the first column. If you register in lightweight mode that we call, then we don't require a restart of the VM, but we give you some basic capabilities such as picking HADR license type or a unified view, which I'll show shortly. But the maximum value of IaaS in the cloud you get only on Azure is full registration, where you get all the benefits listed here and I just spoke about. How do you register it? So when you go to the portal, as you can see in the screenshot at the bottom, you can just click on the automatic registration button. So all this requires you to is at per subscription level, acknowledge that you want the agent installed. Then Microsoft will automatically go and discover all the VMs in your environment and register it for you, so you don't have to do it manually yourself. And there is no privacy data collected from any of these environments. It is still all your data is protected by you, so there should be no concerns in terms of security and privacy. The second challenge that we see is customers do want to migrate to the cloud. They want to bring their lift and shift their SQL Server workloads, but they do not want to manage their environment. They want to let Microsoft take care of managing the environment, like patching, upgrades, high availability, etc. So what do you do in that case? So in this case, Managed Instance provides the best of SQL with best of Azure. It's a happy marriage between the two. So you get all the past benefits plus all the benefits of SQL Server, and you have different deployment choices such as a single managed instance or instance pools. It runs in your network, so it's completely secure and isolated from other customer managed instances. So it gives you resource isolation and network isolation, and you can fully integrate this managed instance with other SQL Server installations such as those running on VM or on-prem, so you have a complete hybrid architecture. Since it runs the latest and greatest version of SQL, it's always evergreen, so you don't have to worry about end of support, etc. A nice customer story which you can also look up is Komatsu. This is a really cool story. They chose Managed Instance because they didn't want to be in the burden of running an operational team to go and take care of patching and hardware upgrades and all the mundane tasks. So they picked managed instance because they needed instance level features for their applications, and they were able to easily move terabytes of data to the cloud and realize a lot of savings, both in cost, like almost 50%, and performance, which is about 25 to 30%. Really happy outcome for them. So do look at their customer story. And finally, Azure SQL database. So in this case, customers pick this if they are building like new cloud-born applications or multi-tenant type applications which do not need instance level capabilities. So you can pick single database as a service or elastic pools. So you can really manage multiple databases in a logical server and save costs. And it provides the industry's leading availability SLA 4 nines and a 5. No other cloud provider provides this. And we have very good RPO and RTO, plus with features like private link and all the other SQL Server security features, you get the best of security along with the best performance that I spoke about from the GigaOM benchmark. A nice story for this deployment option is AccuWeather, which is a weather software, which they picked Azure SQL database because they did not need instance level capabilities, but they needed a way to elastically scale up and scale down their databases, and also integrate with other Azure services such as Power BI and Data Factory, etc. So they can really provide modern applications for their end customers. So now that I've shared a little bit of each of these deployment options, the big question is which one is right under which scenario, right? So let's talk about that. So the three main application patterns that we see customers bring for SQL to the cloud fall under either a migration application. In this case, they're moving existing application and database assets. The second one is app modernization, where they're not only moving the application, but they're also modernizing it in the sense they are making changes to the application and the database to leverage some new features. For example, built-in ML or with like such as R and Python, or integrating with Power BI, or leveraging some analytics features within SQL like column store, etc. So that's another scenario. And the third scenario is if you're building a native cloud application from the startup, like a greenfield application, then you can use SQL also in the cloud as a starting point. So any of these are good scenarios for Azure SQL, and which target you pick depends on two main things. First is what level of control you need, and then what capabilities does your application require. So let's talk about this. For control, if it's a customer managed environment, meaning you as a customer want full control of the environment, such as the all script scenario we discussed. You want everything from the OS to SQL Server to be managed by yourself because you want to pick and choose your own OS, you want to pick and choose your own SQL version, you want to manage when your downtime is, like patching, upgrades, versions, etc. Then going to VM is the best choice because this gives you complete flexibility. But all the operational expenses is you are responsible for that. Microsoft provides the Azure infrastructure, so you don't have to worry about a hardware lifecycle or capacity, because you can spin VMs or size, increase compute or storage capacity of the VM or decrease it on demand. So that's the main burden that's taken away from you. However, there are a lot of customers who want to go even a step further. Is I don't even want to do any of these administrative tasks. Just give me a managed SQL experience for my application and you take care of the rest. So in that case, it's a Microsoft managed environment. Again, as I mentioned earlier, there are two choices. The first choice is if your application needs instance level features like Komatsu did. Some of the features you might want is listed here, such as cross database queries or link servers, SQL agent, SSIS packages, CLR, etc. Then you will need to go to managed instance because all these features are instance level. It's provided for you in the instance, but the instance itself is fully managed for you. What that means is HA is automatically taken care of, backups are automatically taken care of. It runs the latest version, as I mentioned, so you don't have to worry about upgrades and patching. And we support backward compatibility all the way to 2008. So even though you're running the latest SQL Server, you can still run older version applications on the platform. And finally, if your application is built such a way that you don't need instance level features and you just need database level scope features, then SQL database is the target that you would pick. And no matter which PaaS platform you pick, you have further flexibility, which we will talk about, like general purpose, business critical, serverless, hyperscale, etc. So you can choose each of these fine-tuned deployment choices so that you get the best performance and cost savings for your workload. Let's take a quick demo on the unified SQL experience. No matter which deployment option you pick, how easy we have made it for you in the portal to pick and choose and get started. Okay, now let's switch to the portal. As you can see, I'm in the portal now. This is my home page. The way to look at the unified portal is clicking on the Azure SQL tile right on the top. If you don't have this tile, all you have to go is to the search bar and then type Azure SQL and you will find it there. And once you go there, one of the things you will see is we automatically group together all your resources, no matter whether it's single database, as you can see here, or if you want to look at managed instances. If I switch to other page, or virtual machines, you get a single view and different tiers, like you can look at editions, versions, whether it's general purpose, business critical, hyperscale, etc. It gives you a very comprehensive view in a single page. Not just that, how do you get started if you're completely new to Azure? Let's say when you click add, we give you a completely central experience where we show you all the deployment options, and before you pick and choose between these, you can just select the tile and we will talk about all the workload scenarios that are available for each and what is the best deployment option to pick for each one of them. For example, if I pick SQL database, you can see I can choose between serverless, hyperscale and single. I can go to pools. If I pick managed instance, I can do single instance or I can do pools. And now we also support Azure Arc managed instance for your on-prem. And finally, on the VMs, we also have made it easy for you to find SQL VMs in the portal. As you can see, this is the best part where you can pick your own version of SQL and Windows, and it gives you option to search right inside this. If I want SQL 2016, I can go there and pick whether it's Enterprise Edition, Standard Edition, etc. and easily get started. So this is the unified portal experience, and we will look forward to seeing more simplification here as you progress using this. So now let's continue with the presentation. So we spoke about all the different SQL deployment options for PaaS. So now let's double click a little more. In single database, we have two more choices. You can pick either the DTU model, where it comes as a bundled compute, storage, and memory. It gives you, what is it useful for is if you don't want to fine tune each one separately and you just want to pay for throughput, you can pick from different tiers like standard tiers and premium tiers. Our documentation goes into detail on how much performance you get for each tier, and you're done with. So that's pretty straightforward. However, if you want more flexibility, let's say you want to pick certain number of vCores and certain amount of storage, we have the vCore deployment option where you can independently pick your compute and storage. It gives you more flexibility, and also some of our newer offerings such as serverless, hyperscale, and managed instance are available here. Another advantage of the vCore model is it also lets you move your existing licenses. If you already have on-prem SQL licenses with software assurance, you can use Azure Hybrid Benefit and exchange it for vCores. So it really gives you a lot of cost savings if you pick that option. Now, let's look at additional service tiers. So from a performance perspective, there are three. The first one is general purpose tier. It's very suitable for most business workloads. And the other one is the business critical tier. This is really ideal for scenarios where you want extremely low latency, very high availability, and you also want to do a read scale out, so you get a free read replica. What is the difference between general purpose and business critical? So general purpose, the main thing is it runs on remote storage. Think of general purpose as equivalent to failover clustered instance, where you have compute with shared storage. If the compute crashes, then we spin up a new compute and attach to the same storage. So your database will be up and running within a matter of seconds to minutes. And the business critical, think of it as very similar to always on. So you have a primary replica and 3 additional replicas in an always on type configuration. And main difference from a storage perspective is the database runs on the same node as the compute. So it's local high speed SSD. So that's why it's able to do extremely low latency. Plus you can also use one of the replicas for read scale out, so you can spread your workload. So you're not competing for resources on one node. And obviously from a price perspective it's slightly higher, but it gives you a huge performance boost. And finally, our latest and greatest offering is the hyperscale tier. This helps you really future-proof your investments and gives complete flexibility by separating compute and storage, meaning you can start from as low as 2 vCores and scale up to 80 vCores in a single node, and then scale out to 4 replicas. So you can really go up to like 320 cores. Plus on the storage side also you can start from a few gigabytes and go all the way to 100 terabytes. And we'll dive deeper into how it looks. And because of the way it's architected, it gives you extremely high IOPS and low latency and gives you limitless scale. Now let's dive deeper into serverless. So serverless is, as the name implies, it's ideal for scenarios where the workload is either intermittent or unpredictable. So for example, if you have a line of business application like expense reporting, it's not used 24/7. Typically expense reports happens when somebody goes on travel or business related expenses. So it's a very sporadic usage. So in that case, you don't want to spin up a server and be billed for the service even if it's not being used. Another scenario is like dev test, where you don't want a service running all the time. You want to use it when the developer or is online or running some test if it's a test environment. Or in cases where if you're starting new and you don't know how much the workload will need, you can have an elastic compute. So that's another scenario where serverless is ideal. And as you can see on the chart on the right, you set a min and max vCore, and then we will automatically scale up and down the compute between that range as your queries come in. And as you can see, the orange bar here, it tells how much CPU is being used by the query for each second, and we bill you only per second. So that's the lowest granularity in the entire industry. And finally, when the service is not being used, when no queries are running, like it's in the paused state, meaning we will stop the instance and release the compute and take a backup of the database. So you're no longer charged for the compute and you only have to pay for the storage. And if the query resumes again, we will start the compute again and attach the database, and it runs fine. So really huge benefit for workloads which fit this pattern, and savings from a cost perspective. With that, let me show you a quick demo of how serverless works. Alright, here we have a serverless database which I've configured between 0.5 vCore and 8 vCore to scale. So let's go ahead and see what happens when I run a workload. Here I have an OSTress script which I'm going to kick off, which simulates an unpredictable workload. And once it starts running, let me go back here and run the query again. You can see that now more CPUs are online and being used. And you can also look at the last column, which is the total CPU usage called seconds, which tells you that we are billing only per second. That way you're not charged at a much higher rate. And we also built an amazing cache recombination technology. When the workload stops, we will automatically pause the instance and then release it for you. So this way you do not charge for compute. So that's your unpredictable workload demo. Now let's look at the other scenario, which is intermittent workload. So here you can see that I'm running a workload which is not 24/7, so a lot of periods of inactivity. I have configured auto pause delay to 1 hour. Now if I look at both the CPU utilization and the billing charts, you can see that the app CPU build chart shows billed per usage and it's not flat rate. And also you will see gaps in the billing, which means there is no workload running then, so you're not charged. Now even if I go back to 24-hour period, you can see that the workload is very intermittent and a lot of periods of inactivity. So the bill also aligns with the CPU, where you're not charged for the workload when it is not running. So that's serverless for you, which is ideal for both unpredictable and intermittent workloads. Okay, now that we have seen the demo of serverless, let's move on to hyperscale. So what is hyperscale? So here's a simplified diagram of how the architecture looks. There are a lot of boxes here, so let me make it even simpler for you. So at a very high level, you have the compute layer where the queries run for your application. You have your storage layer, which at the very bottom, which is where your database files received. Think of it like where your MDF, LDF files received. This is your remote storage in Azure. And in the middle, we have a layer of cache called page server. So for every database that you create as hyperscale, we create page servers that has a cache of the entire database. So if it's like a 10 terabyte database, we will create multiple page servers to cover the entire 10 terabytes with its own high availability. And then there's additional caches on each of the compute. So when a read query comes, if the query is already in the local compute, if it's already cached in the local buffer pool or the buffer pool extension, the blue box, light blue box, then the query is just returns the data from there. So there's no I/O involved. If there's no data in the cache for that query, then it goes to the page server, and if the page server will always have the data because it has a fully cached copy of your entire database. So still there is no I/O, so it finds the data in your second cache. Same thing with write. When we write a transaction, all you have to do is commit to the landing zone, and then the log service, which is also decoupled, is responsible for flushing that data into the page server, as well as sending the same log records to each of the secondary computes if required on the secondary computes. Another big difference that you will see is, unlike always on where each node has its own copy of database, here is a central copy of page servers, the storage, and the log service. So any data which is written on the primary compute is available near real time on the secondary. So there is no multiple read writes happening of I/O involved from the disk, plus you don't need storage on additional computes. And also another benefit of having a separate compute and storage is scaling up and down either the compute and storage happens within a matter of seconds or minutes. Plus, with features like accelerated database recovery, the database can restore very quickly using snapshot restore and be online within a matter of minutes. So this is how the hyperscale architecture works. You can read more about it at the link provided below. And we also have a session in this conference which you should attend. So with that, let me show you a quick demo of SQL hyperscale in action. Let's take a look at how hyperscale helps you achieve greater read scale. On the left, I have an application which is ingesting data into hyperscale database, and you can see the events per second counter growing. So right now on the right side, I have another application called SQL Query Stress, which runs a read-heavy workload, and I'm going to point it to the same endpoint where the hyperscale database writes are happening. So if I go ahead and click Go, you will see the events per second drop. This is because both the read workload and the write workload are sharing the same database copy instance and compute capacity, which means the workload throughput is reduced. So what we can do to solve this kind of problem is use the read scale out feature of hyperscale. So now on the portal, you can see I can go up to 4 replicas, which I've already configured. Now I'm going to start 4 read query applications at the bottom, as you can see. And the main difference here is if I go to the settings, you can see at the bottom left that I have enabled application intent read only for each of these query stress connections. So which means all of this will go to different read replicas. And I'm going to go ahead and close the one which was connecting to the read write replica. So now if I go ahead and kick all these applications and start the queries, they will all now be hitting the read replica and not the write replica. And you can see the chart on the top that there is no impact to the write endpoint, which is your primary replica, but you get 4 times the read throughput because I'm able to run each of these 4 clients against the read endpoints on the read replicas. Now that we have seen how hyperscale works, let's move on to the next slide. So here we'll be talking about some key use cases for all the different Azure SQL targets that we just spoke about. The first one I have is H&R Block. They're a US-based tax application provider. So if you're filing income taxes within the US, and if you go to their website and file your tax returns there, the data is stored in guess where? SQL Server. So they have been a SQL Server customer for many years, and as they look to modernize out of their on-premises environment to the cloud, their obvious choice was Azure SQL, since they're very familiar with SQL Stack. And features they were using in SQL Server were all instance level across the board. So managed instance was an ideal target for them. They did not want to manage their own environment because they're in the business of building tax applications and not in managing SQL Server. They chose managed instance. And as you can see here at the bottom, from their enterprise data analytics person, this gave them a seamless migration path. And not only that, once they migrated their SQL Server to Azure SQL Managed Instance, they were also able to modernize that workload by connecting to other services in the Azure ecosystem, such as AI and machine learning and Power BI, etc. So this is a really good story. By the way, all these use cases are publicly available. In case you want to read more about it, just go to customers.microsoft.com and look up these customer names under Azure SQL product, and you will find them. The next customer in the story is ClearSale. They are a large e-commerce retail provider, SaaS provider for fraud detection. So if there are any transactions that happen on the e-commerce websites, security is a big important concern for a lot of these software application providers and also the end consumers. So they have built they used to run on-premises environment, and with the volume growth for data as well as their business growth, they couldn't keep up managing their on-prem infrastructure. They needed to future-proof their environment, so they chose hyperscale because it provided them the limitless scale capabilities that they were looking for. They moved their entire application to hyperscale, and now they are running with great performance and price benefits. And not only that, they no longer have to worry about having to upgrade their applications or end of support for SQL Server, etc. Everything is managed, fully managed service for them. And the last customer we have here is Cambrain. So as the name implies, Cambrain is event management camping software. So a lot of their customers book camping sites or events through their portal. As you can see, camping is not a day-to-day 24/7 workload. So it usually happens during specific times of the year, and it's also the volume is unpredictable depending on how the business is doing. So they needed a target which could easily help them manage the unpredictable workload nature and also intermittent workload, because price is important. You don't want to keep paying for a service if you're not using it continuously. And one of the service options that we talked about is Azure SQL Serverless, and this was a great fit for this scenario. What they did was they took their application and the SQL environment and moved it to serverless, and immediately saved huge benefits. Not only that, since serverless also provides elasticity in their scale, since as we discussed, you can set your min and max compute, and the service automatically scales up and down and only bills for how much compute is used. This turned out to be a really good story for Cambrain. Again, find these stories and more, many more Azure SQL stories at customers.microsoft.com. So moving along, we're almost there. The last section we will talk about is recent updates that we have made to the Azure SQL platform with all the deployment choices that we spoke about, the service being continuously updated. There's a lot to cover here. So what I will focus on is covering what's new, meaning which is most recent, as well as what has been released in the last few months, 3 to 6 months, because it's I can imagine for everybody it's be really hard to keep up with every single update. So this will be a good summarized collection in case you want to have a reference. And also on the top right, I have a link to Azure Updates. This is our public announcement portal, and you can actually go there and subscribe to RSS feed. That way you don't have to miss any announcement. It'll come right to your inbox. The next few slides we will cover updates by each deployment option, and you will see the two colors there. If you see as indicated in the bottom left, if you see anything highlighted in blue, those are the most recent of the updates that happened in the last couple of weeks. If you see anything in black, those are the ones that are released in the last 3 to 6 months. So this is a good summary for you. Let's start with managed instance, one of our most popular deployment choices. And here, as you can see, there are a ton of updates. To make it easier for you to follow this along, I have grouped this into themes or categories. And let's go through each one of them, and instead of going to all of them, I will cover the new ones first. And then in the chat, feel free to ask any questions if you have anything about any other of those improvements. The first category is app compatibility. So our goal here is to make sure if you have an existing SQL Server application, your friction to migrate to cloud is minimized or eliminated. So we continuously investigating to make sure the managed instance offering is very close to 100% compatibility with on-prem, so that your applications can run without any code changes. So in that context, some of the new updates I want to highlight is, first one is distributed transactions. This has been a long-standing ask for a lot of customers who have built with MSDTC based applications, whether the distributed transaction is within the same instance between two databases or between two different instances or an application and an instance. Now it's available in preview, so definitely go try it. The second one I want to announce, very happy to announce, is ML services. As you know, in SQL 2017 and 2019, we launched built-in R and Python support. A lot of customers love it because they can do advanced analytics right where their data resides in the database. Now you will be able to do that in managed instance by doing your built-in R and Python related modeling and prediction there. You also remember, if you have the T-SQL predict function, now that's natively available in managed instance also. The third one in this category is support for SSRS catalogs. This has also been a long-standing ask. A lot of customers who have SQL Server also have a lot of SSRS reports, and their catalog is stored in their SQL Server database instance. Now we have the ability to deploy your catalog in managed instance as a fully managed database, so that way you don't have to worry putting it in a VM or a different place and have to manage it separately. Finally, AAD directory readers role. So before, you had to go to your domain admin and had to get privileges if you needed to grant access to AAD admins for your managed instance. Now with this reader role, you don't have to do that. Your domain admin just had to grant permission to the reader role, and then you're all set. Moving on to the next category, network and connectivity. This is of utmost feedback area because of concerns, because it's a public cloud service and a lot of customers have security and compliance requirements. We continue to invest here, and you can see a ton of investments which are in black, which were in the last several months. And most recently, we GA'd global VNet peering. Without this, what customers had to do is, if you had managed instance in two different regions, and most likely you will if you have a production server with DR in a different region as a best practice, you had to set up site-to-site connectivity with VPN, which was a little cumbersome. Plus, in a lot of companies, they didn't want, their security officers didn't want to set up this configuration. So now you have native VNet support between different regions. So you would just take the VNet running in region 1 where managed instance is deployed, and then VNet 2 in a different region where managed instance is deployed, and you can just set up VNet peering, which is a direct connection, and it's very straightforward, and you don't have to worry about site-to-site connectivity. And now these two instances will just seamlessly talk to each other without any other configuration required. Continuing on the security theme, we have TDE with customer managed keys, a big ask, TLS 1.2 support. The older versions of TLS are no longer secure in the industry standards. Most companies have moved to TLS 1.2 or greater. So now you can actually enforce TLS 1.2 as your minimum version in your instance, so that all applications connecting to your instance will be required to use that protocol version or higher. Last but not least in this category, the ever popular data discovery and classification. So this is helping with your data labeling. It discovers your schema and data stored in your database, and you can label it as highly confidential all the way to informational, and then audit access to those classified data. So that feature is also now available for managed instance. The third category we'll talk about is PaaS features and manageability. Again, ton of investments here. I will not go through each one, but one big feedback area that we get is creating managed instance takes a lot of time. If you have deployed it previously, you know the first instance takes time, and that's because the first time we create the instance, we have to create a dedicated virtual cluster for you and then deploy the first instance. Once that's created, the additional instances are created almost in a couple of minutes or so. But customers want more transparency as the instance is being deployed. Just like, remember, when you're installing SQL Server on premises, when the setup runs, you can see each step. So now we have given you a fully transparent provisioning experience where you have management operations, you can progress. Also, if you're resizing the instance, like increasing the compute or reducing, scaling up and scaling down, you can see the progress. So that helps you understand how long it's going to take to get for the changes to be ready. Another area customers wanted is they want to do HA drills for their environment and see how the application behaves if there's an outage. So now you can actually test application fault resiliency, where you can initiate failover through PowerShell, REST API, or Azure CLI. Remember, HA is already built in, as I mentioned earlier. And as we invoke HA, you can test your application connectivity and see how long it will take for your application to start to reconnect once the instance comes back. That way you can adopt the appropriate retry timeout logic so that the application downtime is minimized significantly. Backups, another big area of improvement. It is something that we continue to invest in multiple parts. First is compression. What this does is enable to save you cost, because backup is charged and the storage footprint of the backup depends on what duration you have set up your backup for long-term retention, as well as point-in-time restore, which can go from 0 to 35 days and for long-term retention up to 10 years. So cost is important here. So compression helps you save costs by reducing the footprint of each backup. The other thing is configurable retention. As I just mentioned, you can do that. Not only that, you can also specify where you want your backups restored or stored. So there are three options: LRS, which stands for locally redundant store, which is basically stored in the same region as your instance itself. Zone redundant storage is also local, but it's distributed across multiple data center in a multiple availability zone setup, so that if one data center goes down, your backups are still have additional copies. And the third one is geo-redundant storage, where it can be any other region in Azure around the world. The main difference where customers would want to use LRS, ZRS versus GRS is if they have data residency requirement, where for compliance reasons, the backup has to be in the same country where the instance is deployed. For example, if your instance is running in a country like Singapore, where there's only one Azure region, and if your DR pair is, let's say, in other regions like Hong Kong or Australia, and you don't want your backups to leave Singapore, then you can pick LRS or ZRS. So backups will also stay locally in your country. Last but not least, perf, a big investment area for us. So we continue to invest to make managed instance performance better and better. As I mentioned earlier, Azure is where SQL Server runs best. So managed instance is also one of the key areas where we want to make it the best price performance. So we invested heavily to make TempDB performance as well as data and log performance improved without additional changes for your environment. Remember, this is a managed service, so all these updates come to you for free without any downtime. So little more details on the perf updates for the data and log. So as you can see here, for both general purpose and business critical, the per instance limit is 3 megabytes per second, but we increased the per instance max to 120 megabytes per second from 22. So that's almost 5-time increase. And then you can also see that per dB limit, depending on what file size you're using, you get different throughputs for your log rate. And for business critical, we literally double the log rate from 48 megabits per second to 96 megabits per second, as you can see in the chart on the right. To summarize this whole investment area, you can see at the bottom right the benchmark results that we ran, both TPC and TPC-H, both OLTP and data warehouse type workload, and we saw significant gains, 4 times throughput increase for TPC-C and 23% faster for TPC-H. And if you're doing regular scans, you'll see at least 2 times increase in speed. And if you're doing data ingestion, again 2 to 3 times increase in speed. And all this freely updated for you. You don't have to worry about it, and you will automatically see these benefits for your instance. Now moving on to the second deployment option, we talked about hyperscale, continuing to make it more closer to the non-hyperscale version of single database. So we GA'd change tracking feature. This is for your change feed kind of scenarios. A few big asks from customers who are GODR support. So that's available in preview now. The second one is database copy, which allows you to make a identical copy of your hyperscale database without having to manually export and import data. So this is a really important feature a lot of customers want. And finally, cost savings. So if you are going to use hyperscale for your workload, then definitely do look at reserved instance or reserved capacity. So remember, with multi-year reservations, your price for the instance goes down even further. And then serverless, the last deployment option we looked at, we increased the max vCore limit to 40 vCore from 16 vCores. The auto pause delay right now, the minimum one is 1 hour. We're looking to reduce it to even fewer minutes based on customer feedback. And also we are improving the connectivity story. Remember, when you auto pause and resume, we want to make sure the retry logic for the application is resilient. We are investing in automatic retry. We are investing in making sure your PowerShell and command line interfaces are more complete to help you deploy serverless applications. Now looking at the entire Azure SQL platform, the reason I call it platform is because these investments go to all deployment options, whether you're using managed instance, hyperscale, serverless, etc. So private link GA'd, so this means you can directly connect to the instance through a VNet without having to go through your public endpoint. This addresses a lot of security concerns some folks may have. We invested in UTF-8 support if you need that type of encoding for your data. Resumable index abort. So this allows you to abort your long-running index operations if it is paused. That way it is not interfering with your application workload. This is a common pain point even on premises like index maintenance. If it doesn't finish in maintenance window, a lot of customers will have to cancel it and have to wait for the rollback, and it can cost a lot of blocking. So with this, you don't have to worry about that. We also launched new memory optimized and CPU compute optimized queues. So we have 4 terabyte memory or 128 core instances now available for SQL DB if you have those high performing workloads which need those configurations. The backup storage or redundancy I talked about in the managed instance context. Now it's also available for single database. And continuing with the redundancy area, Now for general purpose tier also, you can deploy the instance in the zone redundant configuration. That way, if that's data center level outages, your instance is immune to some of those smaller blips in power, network, etc. And your outages are pretty much eliminated if it is in the zone redundant configuration. Another cool one is audit of Microsoft support operations. What this means is support if you have an issue with the past service and any of the deployment options, DB or MI, and if you have to open a support ticket, then a Microsoft support engineer or a developer will have to look at your instance and all the logs. What this does is it completely audits every activity performed by Microsoft, so that from a compliance perspective, you have full visibility on what data Microsoft is looking at. Again, remember, we only look at the diagnostic logs. We will not look at any customer data stored in the database. But just to give you an extra peace of mind, this audit support operations let you have full audit trail of what was accessed by a support ticket incident. Then last but not least, moving to the IaaS side on the VMs, we spent some time talking about the IaaS agent extension. So I will definitely give you encouragement to install that, so you get not only business benefits where you can convert from pay-as-you-go to hybrid benefit and move your existing licenses and save costs, but you also get all those automatic benefits if you do it in full mode, where you can do patching, upgrades, simplified HADR deployment, etc. And also, only in Azure, we announced recently, you get for every VM you deploy with SQL, you get a free HA replica and a free DR replica, which means you get literally 3 instances for the price of 1. So take advantage of this by doing this on Azure. Plus, this benefit also applies in a hybrid scenario. For example, if you have SQL Server running on premises in your data center, you can actually set up a DR VM in the cloud on VM. So that gives you full protection in case your data center goes down. At least you have a backup service running in VM in Azure to protect you from outages. Finally, some new updates. We added support for shared disks in Azure, which means you can deploy, if you're deploying failover clustered instance in Azure, you can use Azure shared disk for that configuration. And the simplified Azure AG setup is also something makes it easier for you not to worry about a complicated always on configuration. Especially even on-prem it's hard, but in Azure the steps are even more intense, so we have simplified the whole experience. Take a look at the documentation to understand how to do this. Okay, now that we have seen all the Azure SQL options, customer stories, as well as recent updates, let me quickly walk you through how do you get to the cloud. It's really important to understand the various cloud migration pathways, all the tools, etc. Remember, we have a detailed session on migration here, so please do attend that. With that, let me get started. So there are a few things that help decide how you want to go and where you want to go. First thing is, what is motivating customers to migrate? Things that we see on the infrastructure side are things like data center expiring, so they need to renew the lease. So instead, they could go to Azure and not worry about capacity management. They can also look at not having to worry about hardware and software end of support because on the cloud it's evergreen. And then finally, on the application side, if you want to modernize and keep continuously with the innovation without having to worry about security threats and compliance, etc. And you can really innovate also by connecting to other Azure services, which are also in releasing features and innovating rapidly. So no matter which option you pick, there are a couple of different choices for you. One is rehost. Rehost is basically taking your on-prem application and associated databases and services and moving them as is to Azure infrastructure. And this is easy if you want to do it quickly without having to change, and if you're also under time pressure where you don't have time to rewrite the whole thing and modernize. However, if you do have time to rebuild or re-architect, then you can also modernize both the database layer and the application layer and take the best of SQL and best of cloud and get a really good experience. So with both of these options, let's look at how that will play out. The first is the rehost scenario. Imagine you have a line of business application. It's your typical application, web-based application with a middle tier IaaS and the data layer in SQL Server. This could be hosted on premises in different virtualized environments like VMware or Hyper-V, or it could be even running on other cloud providers. If you would like to move this as a rehost option, then you can use Azure Migrate service. Go to Azure Migrate Hub. This is your central service for you to move your infrastructure assets for a lift and shift server migration. It'll automatically move your entire application layer to a web and app in Azure VM. And for SQL Server, it'll move the entire SQL Server instance to SQL Server in Azure VM. So this is your most seamless lift and shift experience that can get you there the fastest. The second option is refactor. Let's say you want to modernize as you move. Then we also have tools for that. For the web app, you will be using the app service migration tool, which will deploy your app in a managed app service platform in Azure. And then for the data layer, you can use our database migration tools and take it to either SQL DB or managed instance. Remember what to choose when, where we talked about different choices based on your application features, and our tools will help you do that. So both the scenarios are fully covered with all these tools which are available for free. And let's briefly talk about the migration journey itself. So look at datamigration.microsoft.com. It will walk you through all these steps and all the tools you need to do. But at a high level, your migration journey starts with discovery. In this stage, you will actually scan your entire environment to see what all the apps you have, what are the database instances you have, and build the inventory of your entire estate. The next step is very critical, where we do deep assessments to understand all the dependencies, what are the SKUs so that we can right size your target, what are the features you're using so that we can recommend the right destination, whether it's instance or VM or DB or hyperscale. And then the third step is to move the instance or the database itself or the app, right? So this is where you'll use the migration tools. And finally, you're not done there. You still have to figure out when do you want to switch your application users from on-prem or other locations to Azure. So this is your cutover step. So you need to appropriately plan your downtime and initiate the cutover. And our DMS migration provides you with a near zero downtime experience, so you can minimize your downtime. And then finally, after you cut over, you are starting to monitor your Azure usage, and then you basically have to optimize the environment so that you're running the best price performance combination. So these are the high level stages, and our migration session will go into this in more detail. Okay, we talked about the migration methodology. So what are the tools we have on the database side to help you move your SQL Server or other relational databases? So this slide summarizes all the offerings. On the left side, you can see we support SQL Server running on premises or other clouds, and not only SQL, even other databases like Oracle or Postgres, MySQL, etc. And they could be running on AWS, GCP, or even on premises. The first step is to do your discovery and assessments. Here you can leverage either Azure Migrate if you're doing data center, or if you're doing instance or app level, you can use our free migration tools like DMA and SSMA. And then once you do your analysis and address all the issues, you can use our database migration service to move all your databases to your right destination, whether it's managed instance, single database, hyperscale, etc., or your open source databases, MySQL, Postgres, and NoSQL to Cosmos DB. Finally, as I conclude this session, here are some key takeaways to summarize what we talked about. I hope that you had a good understanding of all the deployment choices, customer stories, how they're running successfully, what to choose when, understood what are the recent updates and how do you migrate. Remember that Azure SQL runs best on Azure. It gives you an evergreen platform where you don't have to worry about upgrade and patching or end of support or hardware or data center expiration. You can modernize by integrating with other services like ML, and Power BI and AI, etc. You can really future-proof your investments with hyperscale, which provides limitless scale. And overall, with business benefits like hybrid benefits and reserved instance, you get overall total cost of ownership savings compared to anywhere else. So with that, here's a ton of resources to get you started. Follow us at our Twitter handle at Azure SQL, or tweet using hashtag Azure SQL to engage with us. On the left side, we have free resources which covers in more detail of all the things we talked about today about the Azure SQL family. My colleagues Bob and Anna have published detailed workshop. Take care of the Microsoft Learn Azure SQL fundamentals. So it'll make you an expert in no time. You can take your existing SQL Server skills and make it relevant in Azure by just going through this workshop. And then we have some beginners courses and also a few minute-sized videos so that you can learn more about each features quickly without having to sit through multiple documentation. On the right side, all the analyst benchmarks that they did is published, available for you as resources. And finally, please do look at the aka.ms Microsoft at DPS link. Here we have published list of all the other sessions we are presenting here at DPS. So definitely attend those and have more opportunities to engage us. With that, I would like to thank Amit and his team at DPS who have done a fantastic job of setting up this conference. It's unfortunate that we couldn't be in person, but the good news is because it's virtual, now we can reach a broader audience throughout the day, 24/7, and hope all of you are having a fantastic conference. And it's my pleasure again to come back to this event this year and talk to you. And follow DPS at hashtag DPS 2020. And thank you, folks. And I'll be on chat in case you have questions about this session.